Hi, boys and girls. This is your instructional video for 6.5, graphing inequalities in two variables. Okay. This is one of my favorite algebra topics. I really enjoy this, and I hope you do too. All right, so your goals and your vocabulary are up there, graphing inequalities in two variables. This is very similar to graphing linear equations, okay? You're just graphing linear inequalities. The graph of a linear inequality represents a set of all points that are solutions of the inequality, okay? So when we have an inequality, there's more than one answer. You know, if we have an equation, there's generally one answer. In an inequality, there are lots of answers. Like, for example, x is greater than 2. Well, any number greater than 2 is a solution. So when you're graphing a linear inequality, there are also infinite numbers of points that solve the inequality. So it's a little bit different beast. Here's your terminology. Boundary is one of your vocabulary words. The edge of the graph is a boundary. Depending on the inequality, the boundary will or will not be included in the solution set. What that means is when you graph these lines, sometimes you're going to graph lines and sometimes you're going to graph dashed lines. You know, when we were graphing inequalities, we'd have open circle and closed circle. The dashed line is the linear version of the open circle. It means it's a boundary, but it's not included in the solution set. All right. The boundary divides the coordinate plane into regions called half planes. All right. If you take a coordinate plane, an XY grid, you know, an XY thingy like this, when we graph these, we graph the line, like say, here's my line. Then we divide the plane into two boundaries. This is a piece and this is a piece. Okay. They're called half planes. When the boundary is included, the solution of the linear inequality is a closed half plane. So then if you have a solid line here, it's a closed half plane. If the line is dashed, it's an open half plane. All right, I'm not giving you a test on the vocabulary. These are the steps. The first thing you do is you graph the boundary. You're basically graphing the line, okay? If you have something like, let's say, for example, y is greater than 3x minus 1. That looks like a linear equation, right? The difference is it's got this inequality symbol. Well, what you're going to do is you're going to be thinking in your head that you're graphing a linear equation when you try to find the boundary. All right, your y-intercept is 1. Your slope is 3. You would go ahead and graph the line based on that information. However, instead of drawing a line, this is going to be a dashed line because the line itself is not included in the solution set. It's just the boundary. These are really cool, though. I like these. You're going to want to have your colored pencils handy. All right, graph an inequality with an open half plane. Graph the boundary. Okay, the first thing we have to do is get this in slope-intercept form, okay? We need y by itself on the left, so we're going to subtract 3x from both sides, just like it says, and that gives us negative 2y is less than negative 3x plus 8. I'm putting it in slope-intercept form. Now we have to divide everything by negative 2. Remember, with inequalities, though, if you divide by a negative, you have to switch the sign. So that's going to give us y is greater than 3 halves x minus 4, okay, because we have negative 8 divided by negative 2, or positive 8 divided by negative 2. So then you would go ahead and pretend this says y equals 3 halves x minus 4, but graph it with a dotted line, okay? So our y-intercept is negative 4, 1, 2, 3, 4. We'll put a dot here. And then our slope is 3 halves, so that would be up 3, right 2. I'm going to do it again. Up 3, 1, 2, 3, right 2. And then this is actually going to be a dotted line because it's not or equal to. If it was or equal to, it would have been a solid line. There's no equal to, so this is a dotted line. It's not a very straight dotted line. Now, you have to decide either the points on this side all make this true, or the points on this side all make this true. And the way we decide which side is we pick a test point. And normally, if it's available to you, 0, 0 is a great test point, all right? So if we were going to use the point 0, 0 as our test point, that means that both x and y would be zeros. So we plug it into the equation and see if it makes a true statement. All right. We put 0 in for y is greater than 3/2 times 0 for x minus 4. Well, this wipes itself out, and you end up with 0 is greater than -4. Is that a true statement? Yes, 0 is greater than -4, which means the points on this side of the line make the inequality true, and so we shade this half plane, because all of these points over here on this side of the line make this inequality true. If you plug in the x and their y value, it makes a true statement. Pretty cool. Right? And that's how you graph inequalities. I love these things. This is one of my favorite things when I was in school. All right. So here, sometimes you're going to get them where they're not in slope-intercept form. This one happens to be written in standard form. All right. You want to get this into slope-intercept form first. So we have 3x plus 4y is less than or equal to 0. Okay. Some of the ones I'm going to give you on your paperwork will be in slope-intercept form to begin with, and some will not. Okay, these are not. I'm going to subtract 3x from both sides. I need to check my phone for a second. Okay, my Kroger shopper is shopping, and she's texting me to ask me about substitutions. It's Friday afternoon. I'll do that Instacart thing where they shop for you and they bring it to your house. It's pretty cool. I like it. All right, is less than or equal to -3x, and this 0 is really worthless. He's as worthless as my husband on vacation. Doesn't do anything, so we don't need it. The next thing we're going to do, though, is we need to get y by itself. So we're going to divide both sides by 4. We're dividing by a +4, so we don't need to switch the sign. Our slope is going to be -3/4 x, and our y-intercept, remember on this, is going to be 0 here. Okay, so our y-intercept is 0, so we put a dot here. Our slope is -3/4, so that would be down 3, 1, 2, 3, right 4, 1, 2, 3, 4. Alternatively, we could go up 3 and left 4, 1, 2, 3, 1, 2, 3, 4. And this is going to be a solid line because this is an or equal to. Oh, and I hate drawing solid lines. I'm terrible at it. Oh, yeah, look how bad that is. Oh, yeah, that's horrible. Okay, now we can't use 0, 0 as a test point because it lies on the line. So let's pick something, almost as easy. Let's go with 1, 1, all right? If we replace y with 1 and x with 1, then we get 1 is less than or equal to -3/4. 1 is not less than -3/4. Therefore, that side is not the side that solves it. This side is the side that solves it. So we shade that side. Are we having fun yet? I hope you guys like these as much as I do. Okay, so here we have a check, and they've given you both of these not in slope-intercept form, so that complicates things right away. This little guy over here is pretty easy to fix, though. This would just be y is less than -2x minus 4. I just subtracted 2x from both sides. Now I go ahead and start graphing this. It's going to be a dotted line because this is just a less than. We're starting at -4, 1, 2, 3, 4. Okay, and then my slope is -2, which would be down 2, right 1, but I can't really do that. So I can go up 2, left 1, up 2, left 1, up 2, left 1. Having lots of dots makes this easy for me to graph. You won't need to do, well, you might need to do this because I'm having to do it on paper, so it might help you. All right, so we're going to have a dotted line. I can't even draw a straight dotted line. Oh my gosh, this looks like a ski slope or something. It's a nice negative, right? Okay. Now I need to know what side of the line am I going to shade. Well, 0, 0 is available for this one. So let's put 0 in for y and 0 in for x. Oh, that was -4. Backwards. -4, which gives me 0 is less than -4, which is false. So we're going to shade the other side. All right, since that's false, that means the points on that side don't solve it or don't make it true. So this side does not get shaded. Okay, if we were to pick a point on this side and plug it in, it would have worked. It would have given us a true statement. Okay, over here, this one's going to take a little bit more work. I'm going to subtract x from both sides for starters. That gives me negative 2y is greater than negative x minus 4. She's doing stuff again. She replaced my pork ribs. Okay, now I'm going to divide every term by negative 2. But by dividing by a negative, that means I'm going to have to flip the sign. So I'm going to have y is less than, negative over negative is a positive. This would be positive 1/2 x plus 2. So we go ahead and start graphing this. Our y-intercept is positive 2. Our slope is positive 1/2, which means we go up 1, right 2, up 1, right 2. Solid line or dot dash line. This is a dashed line. Dividing our coordinate grid into half planes, vocabulary word. All right, 0, 0 is open, so let's use that for our test point. 0 is less than 1/2 times 0 plus 2, which gives me 0 is less than 2. It's true, so that means we shade this side of the line. Not too bad, right? These are fun, I like them. And you get to use like colored pencils and stuff. It'd be really super fun. Okay, I went ahead and put this up here because I included it in your book, but in the essence of time, I don't think we're going to mess with the word problems on this section. I just want to teach you how to graph them, so we're not going to be doing this one. Okay, what am I doing here? We're just going to go on and keep solving linear inequalities. Okay, so we have negative 4x plus 7 is greater than or equal to 11. What do you notice about this equation or inequality? I don't see a y. I don't think there's a y, so this is probably going to be a horizontal or a vertical line, okay? So first thing we're going to do is try to get x by itself. So we subtract 7 from both sides, and that gives me negative 4x is greater than or equal to, take 7 away from that, it'd be 4. And then we divide both sides by negative 4. Remember to switch the sign. So we have x is less than or equal to negative 1. Okay? So if this were x is equal to negative 1, this is our x-axis here. Where is x negative 1? It's negative 1 right here. It's also negative 1 here, 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 and here. Okay? So that's going to be our line. It's going to be a vertical line, and it's going to be a solid line because there's an or equal to there. So this is, oh yeah, that's bad. I really draw better on the whiteboard. And then we just have to decide, are we shading to the right or to the left? Well, 0, 0 is available, but we only have an x. So go ahead and substitute 0. You could substitute 0 here, or you can substitute it into the original equation. It doesn't matter. Is 0 less than or equal to negative 1? No. So we're going to be shading the right hand or the left hand side. Okay, it'd be good if I knew my right and my left. So that's what it looks like if you get a vertical line. Now you could get a horizontal line also. I don't think I put any on your practice or your quiz though, just so you know what's going on. Okay, so the graph of y equals 3x minus 4 is shown. Consider the solutions of y is greater than 3x minus 4. Write each point in the appropriate column. Announcements. Okay. Write each point in the appropriate column. In the solution or not in the solution? Well, let's see. We've got the line drawn here. I'm going to use the test point 0, 0 and see what it does with this inequality. So I'm going to use y is greater than 3x minus 4. Okay. If I put 0, 0 in, I get 0 is greater than negative 4, which means 0, 0 is in the solution set. So what points are listed here that would be over here because they're in the solution? Negative 5, negative 3, heck yeah, that's in the solution. 0, -4. 1, 2, 3, 4. It is in the solution because this is a solid line. Oh, no, it's not a solid line. They're trying to trick us. This would have been a dashed line if we had graphed the inequality. And that point lies directly on the line, and the line is not part of the solution set. Oh, they're so tricky. So that is not in the solution. Thought they'd get away with it. 1, -7, definitely not in the solution. 2, 2, like what a ballerina wears. 2, 2 is on the line, so we know if it's on the line, it's not in the solution. -3, 4 is in the solution. I like this question, it's fun. 0, 0 is in the solution, that's our test point. 1, 1. 1, 1 is in the solution. And 4, 2 is not in the solution. Oh, you know what? Oh my gosh, I just started writing in the wrong column. Oh my goodness. 1, 1 is in the solution, and I wrote it in the wrong column. And then 4, 2 is not in the solution, and now it's in the right column. It's Friday, and it's quitting time, and I'm tired. I've been working all day. Okay, now, hey, we got to the practice problems. We're not going to actually do the practice problems in the workbook. I feel like in order to really enjoy graphing inequalities, you need to be able to do this on paper and pencil. So I thought I would do maybe a couple of these. My shopper's checked out. I'm going to have to get home before she gets there. I thought I'd do a couple of these just for fun, and then I'm not gonna assign this. I have a printed one that I'm gonna have you do. All right, so let's see what looks like fun over here. I'm kind of liking number 5. We've got 6x plus 3y is greater than 12. All right, subtracting 6x from both sides gives me 3y is greater than -6x plus 12. Now I need to divide each term by 3, which is a positive number, so there is no need to flip the sign. And it gives me y is greater than -2x plus 4. I was right, this is a fun one. Okay, now my y-intercept is +4. 1, 2, 3, 4 right here. My slope is -2, so it's down 2, right 1, down 2, right 1. It's a dotted line because there's no or equal to. Okay. And now I just need to know what side of the graph to shade. I can use 0, 0 as a test point. That would give me 0 is greater than -2 times 0 plus 4, which means we have 0 is greater than 4, which is not the case. So the shading goes on this side of the graph. Like I said, you're going to be doing these on paper and pencil, so feel free to get out the colored pencils and the gel pens. You'll need a straight edge also. Okay. Maybe let's do one more just for fun. I think you probably get it by now. I'm just doing these because I like doing them. Oh, let's do number 3. It's in slope-intercept form. Y is greater than or equal to 3x minus 1. It is or equal to, so we are graphing a line. We will start at the y-intercept, which is -1. Our slope is +3, so that's up 1, 2, 3, right 1, up 1, 2, 3, right 1. It's a solid line because it has the or equal to. All right, 0, 0 is technically to the left of it, so we can use 0, 0. It's not very obvious because my line is so bad. Let's see if this turns out. 0 is greater than or equal to -1. That does not work out. Therefore, we are going to shade this side, not the 0, 0 side. Okay, so I have a secret word assignment. I did another Ripley's Believe It or Not thing. There is a question over on McGraw-Hill that asks you a question, and the answer is white butterflies. Yes, butterflies who are white. I don't know if those are moths. That's a good question. I bet Hayden probably knows. But anyway, go on over to McGraw-Hill and do the secret word assignment. The answer is white butterflies, and then I will have a paper and pencil practice for you in class. All right, I hope you had as much fun with these inequalities as I did. Have a great one.